Welcome to part 2 of solving rational equations. Here we're going to talk about extraneous solutions. Now, extraneous solutions are solutions that we get from solving the original equation. So we would do all the stuff that we saw in part 1, and we would get 1 or 2 answers. But an extraneous solution is a solution that means it doesn't actually work. The math says that it should, but because of how the rational equation is written, it actually doesn't work. So we got to be careful that we don't say x can be a value that actually makes the function undefined. So we're going to see that sometimes we'll get 2 solutions, but only one of them works, and we might get 1 solution that doesn't work, so there actually is no solutions. So with that said, let's jump into our example problems and see what happens with these extraneous solutions. So here's our first example. We have 3x divided by x minus 3 equals 2x plus 3 divided by x minus 3. So what we're going to try to do is solve this by getting rid of the denominators first. Notice that we already have common denominators, so if we wanted to, we could add these together, but our goal is going to be to get rid of the denominator so that we have no variables in the denominator. To do that, we're going to multiply both sides by x minus 3. Doing that, because x minus 3 is the denominator, we'll cancel out the denominators. And we're left with 3x equals 2x plus 3. Alright, nothing too crazy there. Now this is an Algebra 1 problem. We want to get all the variables on the same side, so I am going to subtract 2x from both sides. 2x minus 2x is 0, 3x minus 2x is 1x, so I've got 1x equals 3. And at this point, we may be thinking we have a solution. But we need to look at the denominators of our problems. And if it makes any of the denominators 0, we have a problem. And if I put 3 into x minus 3, that gives me 0 over here and 0 over there. So that makes our problem undefined. So there is no point, there is no x value where these two functions, or rational expressions, there is no point where these two rational expressions are equal to each other. The math says there should be, but the denominators throw that solution away. So this example has no solution. There was no solution here because it does not work with the denominators. And there's our first example. Okay, we didn't do anything that we didn't do in part 1. We solved, we got the variables out of the denominator and then got the variable alone, but the solution we came up with didn't work. So let's try a second example now. Alright, here's our second example. It looks a little trickier. We've got 2x minus 9 over x minus 7 plus x over 2 equals 5 over x minus 7. And we've got a couple different ways we can approach this, but my first approach is going to be combine like terms. Okay, I am going to take this 5 over x minus 7 and I am going to subtract it from both sides. Minus 5 over x minus 7. Now, since I'm subtracting, it does not have to apply to both pieces. It's only going to apply to this piece because they have common denominators. So I'm still going to have x minus 7 on the bottom, and 2x minus 9 is going to become 2x minus 14 plus x over 2 now equals 0. All right. Well, I don't want it to be equal to 0, so I'm going to move the x over 2 over to that side. So I can have 2x minus 14 over x minus 7 equals negative x over 2. And now we are going to continue to solve. We're going to get our denominators, our variables, out of the denominator, and just, get rid of any fractions we can. So I'm going to multiply both sides by x minus 7 to get rid of the denominator over here. And then I'm also going to multiply both sides by 2 to get rid of the denominator over here. So when I do that, here's what's going to happen. The x minus 7s are going to cancel. And I'm only going to multiply the 2 times that. So I'm going to have 4x minus 28 equals. Now over on this side, the 2's are going to cancel each other. And I'm going to have a negative x times x minus 7. So that's going to give me negative x squared plus 7x. Now we can combine like terms on one side only. So I'm going to add x squared and subtract 7x from both sides. And we are going to have x squared minus 3x minus 28 equals 0, which is now a quadratic equation. And we can solve quadratic equations using either the diamond method or the quadratic formula, just like we did in part 1. I'm going to use the diamond method here because this one is not too terrible. We get x minus 7 and x plus 4 equaling 0, telling us that our solutions are either positive 7 or negative 4. Now we have a little bit of a problem. We have an extraneous solution again, because look at our original. Look at our original all the way up top here. Okay, we've got 2x minus 9 over x minus 7 plus x over 2 equals 5 over x minus 7. Let's just ignore the green writing. If I put 7 into the original equation, I'm going to have 0 in the denominator. So 7 is not going to work. 7 is an extraneous solution. And our only possible solution is x equals negative 4. That is the only time those rational expressions are equal to each other, is when x is negative 4. And there we have it. Hopefully you found these examples useful and you are able to use them to solve future rational equations. Good luck.